we're going to break this M16 bolt. If this was steel, it would be very strong. But this is a 3D printed plastic. Now, I don't have scales or anything to tell me how much pressure I'm putting on this, but you know, you can just kind of watch and get a feel for it. So let's go ahead and let's just snap this thing off. If we, just like that. I mean, so easy, so quick. It just comes right apart. You can see there. The reason for this is because of how 3D printing technology works. I got another one here that's not broken. Basically, these print out on the bed of the printer just like this. So if you don't know how the technology works, the best way I can describe it is like a slinky. So your printer lays down layer by layer of filament on the bed until you have your entire part. Now, a 3D printed part is very strong in certain ways. For instance, if you were to stand it on its head and you push down on it, there's a lot of strength there. If you push in or pull out straight from the sides, there's a lot of strength there. But if you just simply pull up on the layers, it comes right apart. There's not a lot of strength there. That's the layer adhesion, and that's why this M16 bolt just completely comes apart so incredibly easy. So if you've done any 3D printing, you already know that. But I want to talk about how we can design parts in such a way that something like this bolt, while not as strong as steel, can be a lot stronger. Let's take a look at that. So what I've done here is I've printed another M16 bolt. And again, it prints like this. But I've made this in two parts. So here we have this little T that prints like this. You can see the difference in the orientation there. And that's very important because what we're going to do is, if we take this slinky, we've already said, hey, this is the weak point of it, right? But if we could somehow adhere this together so that it wouldn't pull apart, we would have a very strong piece. And that's what we're going to try to do here with this new bolt. So what I'm actually going to do is, I've printed this in two pieces, and I'm using a bolt. You can do this with anything. This could be very useful, for instance, in hobbies like airplanes and stuff where you're printing wings. But the reason I chose a bolt is this is like one of the worst things you could 3D print. Because a bolt is designed, as you put that nut on there, it's trying to pull two pieces together, and it's got that outward pressure. And basically, it does exactly what our slinky does. As you tighten down that nut, it just comes apart, as you saw in my demonstration with the pliers. So what I'm going to do real quick is I'm just going to put some glue in here, and then we're going to insert this in. So what we're going to have when we're done is two pieces of plastic. This will be all the way in, but two pieces of plastic with the grain running opposite of each other. So that'll hopefully give us a stronger final part. You know, I know the kind of the romance to 3D printing is just hit print, come and pick the piece up. But sometimes that's not, that's not a real reasonable expectation for the process. But there are ways we can strengthen the parts by simply taking it and saying, hey, how can I make this into two pieces that we can either epoxy or glue together and then have a much stronger piece in the end. So I'm just going to put some super glue in here real quick, and we'll see how it goes. Okay, so I'm just going to go ahead and put the glue in here. And I'm going to get it down inside there good. I want to make sure it's on all sides as best I can. Whoops, let me get this back in the frame. I'm going to put some up here at the top of the T as well. And just get a little extra down in there. So, oh, I think I got a little too much. Oh well. So we're just going to stick this in then. Shove it down in there and give it a whack with a hammer. Yeah, we got way too much glue. But that's alright, we'll just put some paper down and just hammer it down in there. There we go. Clean up that excess. Alright, and there you have it. So you can see the piece I just hammered it down in, and we'll just let that set up till it gets good and hard now. Okay, so it's been about 10 minutes. I got a little carried away with the amount of glue I used, but that's okay. This should actually cure for about 24 hours, so I don't know how it's going to do, but I've let it sit for a good 10 minutes. Let's just take a real quick look at this one more time here. You can see again, it just completely sheared apart. I can take my fingers and I can just finish it off. I mean, it's that easy. I don't know. It's probably, anyway. don't know if you can see that or not, but it just pulls right apart because, again, even with the best adhesion that you can get on a 3D printer, it's just still not that great. So let's give this one a shot, see if it does any better. Again, should probably let this go for the full 24 hours, but we're just going to try it. So I should be able to break it, but hopefully it'll be a little harder to break than the other way, and that's the thing. The other thing is this doesn't use any more plastic, or material, I should say, depending on what you're printing with. This doesn't actually use any more material. It's the same amount. These were both printed at 100% infill. They were both printed in PLA. Actually, it's just the sample PLA that comes with an ender. So let's see what this one takes. And we're starting to get some separation. Okay, there we go. We got it to break. So what we see here, though, is it's a lot harder to break than the other is. And you can see how it actually stretched the core out. I don't know if you can see that or not in this picture. I know it's kind of washed out. Should use a different color besides white, but that's what I had. So you can see how it just kind of strung it out as opposed to the more just clean snap off, and that's because that center core in there was giving it the strength. I can feel the glue is still wet inside here, so I guess it didn't even have a chance to really set up totally. So maybe you should try it again with 24 hours. It'd be interesting to put it on a weight scale and just see what the difference is. But anyway, just something interesting to think about if you're designing parts. I do have this part in Fusion. I don't know if I can share it down here. If people are interested in knowing more about this, leave it in the comments below, and we'll see what we can do. Thanks. Have a good one.